Screen is visible. Can you see the presentation? Hello.
हाँ सर विजिबल.
Yeah. Okay, we'll continue. Up to what point we have covered in the last lecture? Do you know?
सर
Kunal,
actually
please
लास्ट
tell.
लेक्चरला नव्हतो.
Last lecture. Was there anybody was there from your group? Yes. Pratik, Priyanka, Sagar, Shraddha, Sandhya, Saurabh, Shubham, Vinkita. Do you know up to what point you have covered in last lecture? Huh? Yes. Okay. We'll start with this point. Step up cycloconverters. As like step up chopper or step up transformer, there are step up cycloconverters. Step up transformer is to step up. That means to increase the output will be more than the applied input. Step up chopper is also a booster in which we get the output which will be more than the input applied voltage. Here in cycloconverter also what we need to increase here is frequency, because AC supply are having a 50 hertz. The available AC source, their frequency is 50 hertz. If we want more frequency than 50 hertz or less frequency than 50 hertz, if we have some applications where we need low frequency AC supply, so in such situations we need to convert the 50 hertz AC into either more than 50 hertz, that means 62.5, 75, or 87.5, 100, or less than the input supply frequency, that is 37.5 or 25 or 12.5, like that. So that means you can step down that frequency from 50 to one third and so on, one fourth and one half, etc. And you can increase the frequency twice, thrice, four times, etc. So depending on what you are getting at the output, it is classified as step up or step down cycloconverter. It is AC to AC converter. Only the frequency or the amplitude can be increased, but normally in cycloconverters we are more concerned with the frequency of the output. Here step up means we are increasing the frequency of the output. Here you can see there are two rectifier circuits, you can say here. This is one and this is the other rectifier circuit. It is a center tapped uh, single phase full wave cycloconverter. You can see P1, P2, N1, N2. P1 means the positive half cycle one part, N1 is negative half cycle part. Means this SCR will conduct for the positive part of the first half cycle, whereas this P2 will conduct for the positive part of the second half cycle. Similarly, N1 and N2. N1 will conduct for the negative part of the first half cycle and N2 will conduct for the negative part of the second half cycle. So depending on the input, first half cycle, that is positive, when A is positive with respect to B, this P1 is forward biased and it will conduct. So we'll get some voltage across the load and some current will flow through the load when P1 is forward biased and a gate pulse is applied to it and it is in forward bias. That means A is positive with respect to B. So the current will flow through the path A, P1 load and to the neutral point. Now here the thing is we need to turn off this SCR forcefully. Why? Because we want to increase the frequency of the output. If we keep this SCR for full half cycle in the on state, then you will get the same frequency. So we need to turn it off forcefully so that you will get more frequency. So we can turn it off at suppose 15 degrees. So it will be turned off at this point. Here you can see. यहाँ पे. During positive half cycle, this is the path of flow of current through the load and SCR. And you will get this part. The output is connected to the input. The output will take the nature of the input. So when P1 is conducting, you will get this load voltage. At this point, we are turning off the SCR1, that is P1, by forcefully applying a forced commutation, and it will be turned off at this point. And यहाँ पे क्या कर रहे हैं हम लोग? At this point, we are turning on this N2 SCR because this will be in the forward bias. In positive half cycle, P1 and N2 are forward bias. So this it is conducting in positive half cycle. Now we are turning off P2, P1 here and turning on N2. So the current will be flowing through the path. Now this point is positive, so the current will flow through this path, and then N2 and back to the B. B terminal will be positive. Sorry, B will be negative during positive half cycle. So the current will be flowing through this path. N2 and load Bn. It will start from N and through N2 it will come back to B. So it will be closing the path. You can see this path, the current during this period from where SCR1 is turned off and N2 is turned on, the flow of current is through this path. N terminal, then this way N2 and back to the B terminal. So you will get this part, negative part of the output voltage. Here again we are turning off this conducting SCR N2, and how it is turned off? By applying a forced commutation method. So here N2 is turned off, and again we are turning on P1 here to get the positive part of the output voltage. Similarly, at this point we are turning off P1 and turning on N2. So we get 4 half cycles here. You can see 1, 2, 3, 4. So this type of output is available across the load when we switch on and switch off these two SCRs one by one, P1 and N2, P1 and N2, because they are in forward bias during positive half cycle. So the frequency is 4 times the frequency of the input. Frequency of the output voltage is 4 times greater than the frequency of the input voltage. This way we can increase the frequency of the output, which is called as step-up cycloconverter. During a negative half cycle, what happens? N1 and P2 are forward bias. So P2 and N1 will be turned on and off one by one to get the output voltage of 4 times frequency than the input voltage frequency. So how they will conduct? Here you can see during negative half cycle, this P2 is forward biased. This is positive. This terminal is positive with respect to this. So P2 is forward biased, and once we apply the gate pulse to the thyristor P2, it will start conducting and the current will flow through this path P2, then load and back to N. So the current is flowing in the opposite direction when P2 is conducting this way. So you will get this voltage. It will take the shape of this type. So P2 current is flowing in the opposite direction. यहाँ पे current कैसे flow हो रहा है? Downward, यहाँ पे upward है. Right? So you are getting this positive part of the half cycle. Now at this point, we are turning off the SCR P2 by applying a forced commutation. So here P2 is turned off and we are applying a gate pulse to the SCR N1 as it is in the forward bias, and it will start conducting and the load current will flow in the opposite direction. Now here the current is flowing in this direction. Through the load, it is negative to positive. That means you can see the current is negative here and you will get the shape like this. So this is first half cycle, second half cycle. When P2 is conducting, you will get positive half cycle. When N1 is conducting, you will get negative half cycle. Similarly, this repeats P2 and N1. So you get 4 half cycles when P2 and N1 are conducting one by one. So the frequency of the output is 4 times the frequency of the input. This way we are getting the AC output voltage whose frequency is greater than the frequency of the input. That's why it is called as a step-up cycloconverter. Cycloconverter means AC to AC. The input is AC, the output is AC. The difference is either the amplitude or frequency or both amplitude and frequency will be varied. Generally, we deal with the change in frequency. We want to have a lower or higher frequency at the output. Now, this was a case of center tap transformer midpoint configuration, you can say, and similar is cycloconverter which uses bridge type as like rectifier. As like rectifiers, there are cycloconverters also. That means center tapped or full bridge. Here you can see instead of one SCR at a time, there will be 2 SCRs conducting for every half cycle. Here you can see T1 and T4 will conduct during the positive half cycle, and N1 N3 and N2 will conduct for positive negative half cycle. Similarly, T2 and T3 and N1 and N4. So these pairs will be conducting for the half cycle. That means instead of single SCR in center tap, ब्रिज कॉन्फ़िगरेशन में दो SCRs कंडक्ट करेंगे. And this is positive converter and negative converter. This will generate the positive half cycle part and this will generate the negative half cycle part. And the current through the load will be, when positive half cycle is there, there will be a conduction of current from top to down, and when negative converter is activated, the current will be flowing from down to top. So this way you will get the full wave rectified output, you can see, but it is not a rectifier case, it is a cycloconverter, but this will act as rectifiers. Now what is changed here is why it is not rectifier, because we are turning off these SCRs forcefully in between, and we are getting positive negative parts. Here you can see during positive half cycle T1, the T1 and T4 will be forward biased and they will be triggered and they will be turned on. You can see here and when we apply the input, T1 is forward biased, it is triggered and the current will flow through this T1 load, T4 and back to the negative terminal of the supply. Similarly, during the positive half cycle itself, when this positive half cycle N3 and N2 will be conducting. So during positive half cycle itself, we are turning off T1 and T4 in between, not allowing to conduct for full half cycle. And after that, we are turning on N3 and N2. So that current will be flowing through the path V in N3 load and N2 back to the negative terminal of the supply. So we are getting positive half cycle when T1 and T4 are conducting and negative half cycle when N3 and N2 are conducting. During positive half cycle of the input, we are getting positive half cycle and negative half cycle of the output. So you can turn on and turn off these pairs twice to get the frequency 4 times than the input frequency. During negative half cycle, what happens? For positive half cycle of the output, which SCRs are forward biased, T2, the current will flow through the path. This is positive now. During negative half cycle, current will flow through T2 load and through T3 it will come back to the negative terminal of the input. So this will form a positive part of the second half cycle. That means positive part of the negative half cycle of the input. So during that, we are turning off these two SCRs T2 and T3 and turning on the pair of SCRs N1 and N4. So during negative half cycle itself, the current will be flowing through the path this way. N4 is forward biased and it will flow through N4 load and through N1 it will come back to the negative terminal of the supply. So this will happen during negative half cycle. So we'll get positive part and negative part in this way. Here when T1 and T4 are conducting, T1 and T4 are conducting, you will get this part flowing in the forward bias. Here we are turning off the pair of SCRs T1 and T4 and turning on pair of SCRs N2 and N3, N2 and N3 during positive half cycle of the input. So when we turn on N2 and N3, we'll get negative part of the output. Here again we are turning off N2 and N3 and turning on T1 and T4, so we'll get the positive part of the output. Here again we are turning off T1 and T4 and turning on N2 and N3, so you'll get the negative part of the output. So how many half cycles are there in positive half cycle of the input? 1, 2, 3, 4. 4 half cycles are available at the output. So the frequency of the output is equal to the 4 times frequency of the input. So during negative half cycle, this sequence is there, which SCRs will conduct. initially T2, T3, this positive part, T through T4, sorry, T2, T3, and for negative part, N1, N4, N1, N4, and positive T2, T3, and negative N1, N4. So you will get the output frequency which is greater than the input frequency. So already we have covered step down, and now today we have completed step up. This was step down. Here during two half cycles of the input, we are getting one half cycle of the output. That means the frequency is reduced to 1/4. एक full cycle में हमने 4 times output less. So it is F0 is equal to 1/4 into Fin. This is case of step down cyclo converter. So we have covered step up and step down single phase to single phase cyclo converters, midpoint configuration and bridge configuration. About three phase cyclo converters we'll see in the next lecture, and that will be the last part of our syllabus, three phase cyclo converters. I will stop sharing the screen. Okay. Just I will take the attendance. ठीक आहे.
ओके सर.
ओके बाय.
बाय सर. थँक्यू सर.
आणि लेक्चर आहे किंवा नाही जरा थोडस हे करत जावा ना, अपडेट करत जावा.
ओके सर, चेक करतो, विचारतो.
हा 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 ठीक आहे.
ओके सर. बाय.
उद्याचं आहे की नाही मला सांग उद्या.
सर उद्या एक्झाम आहे ना आमची दुपारी 3:15 ला.
हा ओके ओके. मग नसणार ना लेक्चर?
नाही मग नसेल लेक्चर उद्या.
ओके ओके ठीक.
हा ओके सर.